Okay, so we're going to do an example of determining the potential and the electric field. And we're going to do this with 3 point charges which are shown in this figure. So we've got two negative point charges located on the y-axis, and we have a positive point charge located on the z-axis. So the first thing I'm going to do is, what we want to do is we want to determine what the electric field would be out here. Okay, so quite far away from the origin. So the first thing we're going to do is going to determine what our monopole moment is. Okay, so a monopole moment depends on total charge Q, and the total charge is going to be equal to minus Q. We've got two negative charges and we've got a positive charge. So monopole potential is going to be equal to 1 over 4 pi epsilon naught by minus Q divided by R. Okay, so that's the first bit done. Now for the second bit, what we're going to do is determine what the dipole moment is. And that's going to have a contribution from each of those charges. Okay, so our dipole moment essentially just going to be a summation of R prime by the charge. So in this situation, we have a charge which is located on the positive y-axis, it's minus q, so I have a minus aq y hat. We've got a negative charge on the negative y-axis, so that's going to become a positive, so positive aq y hat. And we have a positive point charge on the z-axis, so we've got a plus aq z hat. So we see our dipole moment is equal to aq z hat. So now what we need to do is need to write z hat in terms of r hat and theta hat. So z hat can be written as cos theta r hat minus sine theta theta hat. Okay, so our dipole moment P now becomes aq by cos theta r hat minus sine theta theta hat. Okay, so P dot r hat will equal to aq cos theta. So therefore our potential for a dipole will just equal 1 over 4 pi epsilon naught by aq cos theta divided by r squared. Okay, so that's that's our dipole potential. So what does that make our total potential? Well, our total potential now, V, which depends on r and theta, will equal q divided by 4 pi epsilon naught by minus 1 over r plus a cos theta over r squared. Okay, so there is our dipole potential. Now, what we want to do here now is determine what our electric field is. So to determine what our electric field is, we take the derivative of our potential with respect to r and respect to theta, and this will give us our final answer. So electric field depends on r and theta will equal q divided by 4 pi epsilon naught Then we take the derivatives of these with respect to r and respect to theta. And remember, it's in spherical coordinates, so we have minus 1 over r squared r hat plus 2a cos theta over r cubed plus a sine theta over r cubed. This is a r hat, this is theta hat. Okay, so just write this out just a little bit neater. So it'll be equal to q over 4 pi epsilon naught by minus 1 over r squared plus a divided by r cubed into 2 cos theta r hat plus sine theta theta hat. Okay, so there is our electric field for that charge configuration. And there should be an r hat in here.